Hello and welcome to the second video on the Save My STEM Physics channel. This lesson is going to be about uncertainties in measurements and readings, what a measurement and a reading is, and ideas of resolution, also going over key terminology such as accuracy and precision. This falls under just the basic section of the Physics A level of what I'm going to put in my playlists. And this is just basic knowledge which is going to be tested throughout all of your physics papers, stuff that you need to make sure you're getting right so that you can get higher marks. Now, let's start off with the idea of what is resolution. Resolution, I should probably have this pre-written down because it's going to take a while. Resolution is the smallest change in the quantity measured on a measuring instrument that gives a perceptible change. That definition is from the AQA specification, so if you've got any gripes with it, that ain't my problem. A reading is an output of an instrument without, W/O meaning without, uh, two comparable values/results. So, for example, something like a voltmeter or a multimeter that produces ohms or amperes, that will give you one value, one result to read off of, making it a reading. A measurement is a reading with two comparable results. So, for example, we've got my ruler here. This has, let's say we want to read the length of the word measurement that I have written down here. We want to zero it at the start of the letter M and then go down from the tip of the letter T, and that's going to give us a value of about 6.8. So we have 6.8 centimeters for the length of the word measurement that I have written down here. I'll just get an arrow on that. Obviously, I can't read the voltage of the word reading. But yeah, that's just an example for measurement. Now, the reason that's two comparable values is because if you look, we are zeroing it. That 0 centimeters is a comparable value. One important thing to note is that a thermometer gives a reading and not a measurement, because thermometers have negative values, and you do not need to compare the negative values or the bottom of the thermometer to where you're reading it off from to get a suitable value, which makes a thermometer reading a reading. Now, uncertainties arise from the fact that equipment is not perfect. There is slight uncertainty in the suitability of equipment, and these come from our resolutions. Now, so uncertainty of a resolution, sorry, if you just let me, uncertainty of a reading, not a resolution, I misspoke there, equals plus or minus half the resolution. Uncertainty of a measurement equals plus or minus the resolution. So the way I like to think about it is, for a measurement, I'm taking two readings, so I'm going to get double the uncertainty of a reading. Same applies if I take 3 readings, I'm going to get triple the uncertainty. 4 readings, I'm going to get 4 times the uncertainty of a reading, which is just 2 resolutions. Now, these apply for absolute uncertainties, so I'm just going to get that written there. That's an absolute uncertainty. Now, for percentage uncertainties, what you want to do is you want to do the absolute uncertainty over the value. So you're just going to divide it and then multiply it by 100 because it's a percentage. So for example, the absolute uncertainty in the measurement of 6.8 was 0.1 centimeters, and then the absolute uncertainty, the value was 6.8. Because they're both in centimeters, I don't have to bother making it into meters, because it would just be 0.1 times 10 to the minus 2 over 6.8 times 10 to the minus 2, and those times 10 to the minus 2 cancel out. So we just go back to 0.1 over 6.8. Now if I go to my calculator and do 0.1 over 6.8, and then multiply that by 100 to get a percentage, that comes out at about 1.47%. And that is just an absolute uncertainty for a measurement. For a reading, make sure you're doing half the resolution, and those are just the basics of a percentage uncertainty. Now, when we're adding two numerical values together, so let's say we have 6.8 centimeters, we're just going to write in our plus or minus 0.1 there, and then we add our, what's a random value which might fit? We'll do the length of the word uncertainty. That's going to go down to about 4.4, 4.5. So we'll do 4.4 plus or minus 0.1. Important to note that I have got my uncertainty in there because I didn't quite know if it was 4.4 or 4.5. And that same logic applies to all uncertainties. So adding these together is quite simple. You can just do 6.8 plus 4.4 to get 11.2. And then we're going to add our uncertainties together, so it's plus or minus 0.2. Another way you can think about this is you can do what's the lower bound of 6.8 plus or minus 0.1, 6.7, and what's the lower bound of 4.4 plus or minus 0.1, 4.3. You know, it's because we're taking negative 0.1 away from both, and adding those together gives us 11. 11.2 minus 0.2 is 11. The same logic applies if we do 6.9, the upper bound of the first one, plus 4.5, the upper bound of the second one, we get 11.4. 11.2 plus 0.2 is 11.4. So our logic there checks out, and hopefully that should make sense. However, when multiplying, you must use percentage uncertainty. So if I do 6.8 times 4.4, what I must do is, obviously we have our 6.8 times 4.4, which putting into a calculator gives us 29.92. However, we must work with our percentage uncertainties now. We're going to do 0.1 times by 6.8. 0.1 over 6.8 and 0.1 over 4.4. Now, if you just give me a second to logic some stuff out. Remember to times your values, each value by 100, so we're getting it as a percentage. And if you'll just give me a second, I will cut this part out of the video. Okay, sorry, I am back after the video, I hope cut just then. And So what you want to do is you want to add your percentage uncertainties together. Remember, we're just timesing each one by 100 to make sure that it's make sure that it's a percentage. Sorry, we're going to get 10 over 6.8 plus 10 over 4.4, and using our calculators that will give us a value of 3.74%. And that is our new percentage uncertainty in that value, 3.74. So now we can just do 29.92 plus or minus 3.74%. Or importantly, what we can do is we can convert that to an absolute uncertainty. 3.74 over 100 times by 29.92, and that will give you a value of 1.12. And all is well. So that's how you use percentage, uncertainties, absolute uncertainties, measurement, and readings. We have one final thing that we need to get sorted out, and those are accuracy and precision. These two words are not interchangeable, and I've had many warnings about the fact that these two words are not interchangeable. Accuracy is the proximity of a mean value, or any value for that matter, but typically a mean value, mean experimental value to the true value. Precision is the proximity of experimental values around the mean. So, in other words, precision is your range, and accuracy is how close your mean is to the value that it should be. And that concludes our lesson for this video. Hope this has helped. If you are struggling with anything, please drop a comment. Thanks so much for watching.